Good day everyone, this is Engineer EMV and welcome to my channel. Before we proceed, hit the like button and subscribe for more civil engineering topics and practice problems in my channel. So as you can see, we are asked to find the area of the shaded region. This problem can also be solved by the principles of plane geometry. But for me, it will be easier if we are going to use integral calculus. So let us proceed to the problem. So we have a figure in which there is a square that has 10 units on each side and some curves drawn in the square. But if you are going to look closely, there is a quarter circle formed since the sides of the square will serve as the radius of the quarter circle. Now, if these quarter circles intersect at each other, by common sense, it will be on the midpoint of one side. So let us draw a line that will pass through the points of intersection of the quarter circles, and it will be 5 units since it is on the midpoint of one side. Now, we can isolate our quarter circle with the corresponding lines as its boundaries. So I have the line. So to get the total area of the shaded region, we can multiply this area into 8 because it is composed of 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. So we will use integration in solving for this unknown area. By isolating it and converting it into the Cartesian plane, we can set our quarter circle and lines. So this line represents the line that passes through the intersection of the circles. And this line represents the boundaries of the circle, in which the center of the quarter circle is at the origin 0, 0. So before we solve the unknown area, we should first get the equation of the circle. So to get the equation of the circle where its center is at the origin and has a radius of 10, we can say that the equation of the quarter circle is equal to x squared plus y squared is equal to r squared. By substituting our values, x squared plus y squared is equal to, our r is 10 squared. So that will be our equation of the circle that has a center on the origin and a radius of 10. To summarize up the lines and the points that we are going to use, we have y is equal to 5, x is equal to 10, and x squared plus y squared is equal to 100. Now we can solve for the unknown area. Here I will be using horizontal strip to solve the area. So we follow the rule that the endpoints of the strip will lie on the different curve. Then we isolate the strip. Since we are using horizontal strip, our width is dy. And this will be our length, x. So to solve for the value of x, we measure it from the positive y-axis. This will be x outer and this will be x inner. To solve for x, we can subtract the values of x outer minus x inner. This will be dy. So our x outer will be the line x is equal to 10. And our x inner will be our quarter circle. So let us convert our equation. X squared plus y squared equal to 100 will now be equal to x squared is equal to 100 minus y squared. By simplifying, our x is equal to the square root of 100 minus y squared. Our final value for the length of the horizontal strip, x is equal to 10 minus square root of 100 minus y squared. So by further computation, we can now solve by integral. By further computation, let us now solve for the total area. So area is equal to integral of x dy. Now we substitute our value, the integral of 10 minus square root of 100 minus y squared multiplied by dy. Since we are using horizontal strip, our strip will run through from 0 to y is equal to 5. And by using our calculator to solve, area is equal to 2.169 square units. But that is not our final answer since we need to multiply it by 8 times to solve for the total area. Since we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 2.169, our total area is equal to 17.355 square units. And that is our final answer. That's all for this video. I hope you've learned something. And if you have questions, inquiries, and topics in mind, just comment it down below. And let's see what will be our next topic in our next videos. Don't forget to hit the like button and subscribe for more civil engineering topics and practice problems by Engineer EMV.